all the colors gone.
Well,
No, I know. People know that. When you go from JPEG. Not all of them, but depends on the edit. I think Photoshop only does that. As far as color.
okay, we want this one, right?
Yeah.
Ezekiel, that thing?
Yes. Yeah. Here.
Oh no, we're putting your pictures on, Ezekiel.
It doesn't
Okay.
like this one.
Okay.
It won't accept that one.
Okay.
Having any troubles with them?
Yeah, we're having a bunch of trouble with the pictures. It's just the software that.
It's the two galaxy shots you sent me,
But
Ezekiel.
we're having problems with mine too, so don't feel bad.
They're just JPEGs. You think it
Well,
would
no,
work?
they were PNG, but I transferred them. So
You should have sent me the PNGs.
I have it in my desktop too. So if you want me to share my screen and show you the pictures, I can do that as well. Okay.
Well, hello, everybody. This is Scott Roberts with Explore Scientific and the Explore Alliance. And it's my pleasure to bring you guys the current episode of Focus on Astrophotography. We have a special guest today, all the way from Puerto Rico. But we're going to get started with Annie Scarborough, who's going to give us some insight into the going-ons of the Explore Alliance. So, Annie, how you doing today?
I'm doing good. I'm doing good. We had a little nice little party for an employee that's going to have two babies. So
twins. That's right.
Yep. So I've got a little bit of sugar in me. It's great. Wonderful. Now I just need coffee and we'll be good. But yeah, we Explore Alliance is growing. I just uploaded I think 4 or 5 new members today. We actually met the numbers for that new plugin on our website, so we had to actually move up to that next level of numbers so we can have more people come
continue to expand, right?
Continue to expand. So it's been really good. I am a little curious because I thought I saw somebody on the chat say that this is their first time watching.
Oh, really? Okay. Well, let's see.
So I'm kind of curious.
So let's look at who's on with us right now. We have Richard Grace. He signed on first. Martin Eastburn, who's, a lot of these people are always on. Mike Wiesner says hello. We've got Beatrice Hines. She says hello, Photon Chasers. Very appropriate. Book Davies. Let's see. Chuck Staw. His name is Shailendra Sharma out of London. So that's cool. And Harold Locke's on with us. Stephen Hauser says hello from Smoky, Idaho. Martin Eastburn says, here comes some howdy. Here comes some howdy, Mike, howdy, Explore, and howdy, Book, Scott, Beatrice, and all. Okay, Martin. Cameron Gillis is on chat and also going to be presenting today, as usual. And let's see, who else? Annie, you're on, of course. Ernest Costa. Hello, new to the show. Welcome, Ernest. That's great. And then we've got Piston, or what is it? I'm not getting it here.
Kit.
Paitien van Staden. Okay. He said, this guy says, I got my first telescope now. I'm trying to figure out anything I can. Okay, well, you came through the right place.
Yep, that's right.
Yeah. And let's see, who else is on with us? Jim's Astro. Very nice. Richard Lighthill. Hello, everybody from southeastern Arizona. I'm sorry, I'm butchering this name here. Paitai van Staden says hello from South Africa. So hello.
That's
great.
Awesome.
Yep.
That's awesome.
And let's see, Ernie Costa's from El Cajon, California. That's my old neck of the woods. And Richard Lighthill says thunderstorm is passing overhead right now. So, well, it's been a interesting week overall. We are wrapping up. Actually, if I look back on all of our programming since before August 4th, we started our first Global Star Party. That was last year. Our next Global Star Party will be Global Star Party number 58. That will happen in 2 weeks from now. You're going to want to check that out. The theme of that Global Star Party will be moons and moonlets. On another special guest that we're going to have on February 25th will be Dr. Linda Spilker and hopefully her husband, Tom Spilker. Both Linda and Tom were on the original Voyager mission the Voyager 1 and 2 spacecraft. I think the first one launched in 1976. These spacecraft are still flying. They still communicate with them. And they still, as of just a few years ago, they made a course correction for one where they fired up the engine on the spacecraft, and it hadn't been fired in 35 years. Okay, and it was a success. So that is totally cool. Both of these spacecraft are now in interstellar space, and that makes the human population a spacefaring species with some of our appliances now in interstellar space. So, you know, that's beyond sci-fi for me. That's just so cool. But she will definitely be on. Hopefully, her husband Tom. She's made this loop from going from the Voyager mission when she was an intern, coming out of university. She got an internship at JPL. That internship got her on the Voyager team to begin with. Then she went on to be one of the principal scientists of the Cassini space mission to Mars, or excuse me, to Saturn. And so she did that whole mission. And now she's made this full loop. She's back on Voyager. So it's nothing cooler than that. We also have the virtual Alcon event, which is coming up. So Annie, maybe you can tell them more about some of these events that are coming.
So yeah, we have quite a few things, quite a few things on the calendar coming up. Let me see if I can share my screen so you guys can see. So here's our home. Well, this is not our home page, but if you go to explorescientificusa.com, this is our home page. You'll hover over to Explore Alliance, and then I usually go the back way, so give me just a second. Explore Alliance Live, right here, and then you'll scroll down, and this is all of our stuff that we have on the calendar. These are hyperlinks, so like Global Star Party will take you to our actual page, and here's all the global star parties that Scott was just talking about. You know, we've been doing this since August of last year, and so you can literally pull all those and watch them. If you want to go back that far. I mean, hey, everybody has what, Netflix marathons. You could have a global star party marathon.
Yeah, you can watch a new program every week, for sure.
Yeah.
And there's a ton of knowledge that's buried in these global star parties. Lots of great lectures. You know, I mean, to me, if you just watched all of that, you would have an incredible knowledge base to pull from. So.
Yeah. So, and then if you go back to the calendar, this link takes you to our Explore Alliance page, and there's a little bit of information on what that is. You know, we have somebody new on the show. It's just a membership we have if you have product, to kind of keep you in the loop, get information and discounts, and be able to enter contests and things like that. And right now we have an astrophotography contest going on for galaxies, and there's some great prizes with that. But this is updated frequently. I think I have it updated to September is what I have. And you can literally click on these things, this Astronomical League conference. And if you click on it, it will take you to the page that, you know, with information and things like that, to help you, learn more about whatever it is that's on there. Sorry, I'm a little scatterbrained at this moment.
She's a little overcome by that really sweet piece of cake that she just had a little while ago.
Yes, I don't normally eat.
It was a baby shower. I'd never been to a baby shower before, so it's my first time.
But I wanted to, you were talking about global star parties.
Yeah.
I just kind of wanted to hit home on our affiliate organizations. We have some great affiliate organizations, and one of them that is going to be happening at the beginning of the year is the Winter Star Party.
Yeah.
And in fact, I was talking with Scott about it. I scrolled down and I started reading this story about how the Southern Cross Astronomical Society started. It is amazing. It started with a 5-inch refracting telescope.
Very cool.
He went out and he started using that, and and it, you know, it grew and it grew and it grew. And then when he finally passed away, he wanted his items to go to a nonprofit. And so they made this Astronomical Society that's still going today. I mean, it started in 1922, 1923 is whenever he started doing that. And it's amazing. I looked at Scott and I was like, he started this with a 5-inch refractor. It's like, that's crazy.
All it takes.
You know? And so it's just being able to educate and spark an interest in people that, you know, for them to understand, to stop looking down or the things around them, but there's more to the earth than just that. And so, but this winter star party is pretty amazing. They are actually going to be having their event. You're going to be able to actually go to their event this year. And so this is their website. I was like, I kind of want to go camping in one of these. This is really nice. So, but it's a great viewing, especially in the winter time. You know, us in Arkansas get really cold, probably not as cold as Canadians or people everywhere, but you know, it would be nice to be able to go somewhere warm for a little bit and especially experience the dark skies. And so, but yeah, that's just, I mean, they're one of our affiliate programs or organizations. And so that, you know, we have quite a few like that, and we're always looking for new ones. And so, so you can go to that directory and look and see what we have. It'll also, you know, you can see what they're doing, and if there's anything close to you, or if you want to travel or whatever you want. There's opportunities everywhere, all over the globe to be able to viewing. And so, but I just wanted to kind of touch base because I thought that was pretty crazy that it started with 5-inch refractor.
Yeah,
and it's still going.
If you think of the probably literally, you know, tens of thousands or maybe over 100,000 people, probably well over 100,000 people have been touched by this gentleman and the Southern Cross Astronomical Society, you know, over all those years. I mean, some of the star parties that guy held, I keep calling him that guy. I'm forgetting his name right now, but the guy that started the Southern Cross Astronomical Society, you know, he had star parties with like thousands of people showing up, you know. So this was in Miami. So he basically gets, you know, he visits down there. He sees the Southern Cross for the first time in his life because it's such a southern latitude. And, you know, it changes his life. He goes and buys the telescope that Annie was talking about. And, you know, step by step, they got an army of astronomers out there. Now this is back in the 20s. So they had a multimedia show. Okay. So they had live lecturers. They had, I guess, lantern slides or whatever, but they're projecting images of the sky up on a giant screen. Okay. And I just think it's amazing, you know, what these guys were doing. So,
well, I mean, it is amazing. You know, at one point it states that 2,000 people at one time would come and just wait to view out of 7 telescopes. He only had 7 telescopes. And I'm just like, that's crazy. You really want to, I mean, it really sparked something. And so it was really neat to read that story and learn about that Astronomical Society. So how they started. So
our southern viewers, they've seen it. And I went down to Argentina for a while, and the Southern Cross is the most prominent. I mean, it is there, and you don't miss it. So I can see where it affected him, because I mean, it's like our Big Dipper. I mean, you see it or Orion, and you know what you're looking at. Yeah.
Yeah,
That's
you
cool.
know, I know you were saying only a 5-inch, but I wouldn't mind a 5-inch refractor. That's a nice machine. Yeah, that's a beautiful instrument.
Well, and I don't mean it like that, like, oh, you know, just a 5. I mean, but still, it's just kind of like, you know, we have people that want the biggest and the, you know, because they can see so much of the sky, and so, and it doesn't always take that. You don't have to have the biggest, most expensive telescope to share that experience with somebody. It, you know, it can be something small. I mean, my son has a Galileo scope and he loves it. You know, I mean, it's tiny. I mean, it's not about the instrument you're using. It's about the experience you're having.
that's right. That's
Yes.
absolutely right.
Actually, what you probably want when you go to the, anyone, a good pair of binoculars. When you go down there, there's so much Milky Way. You'd be just having a blast with a pair of binoculars. Large and small Magellanic Clouds, the center of the galaxy. Oh man, yeah, that would be a blast.
Well,
That's cool.
Before the mothership gets going too far, I want to thank Captain Roberts for reading our crew list out, or our passenger list out to everybody. We've had the crew list here, and we've just been assigned our titles.
Chief of the boat.
And you might have heard that in the background. But we know, obviously, our pilot flying us around, figuring out where we're going is Captain Roberts. And we've got our sailing master.
Chief of the boat.
He likes, well, I guess it wouldn't work without you. You're in the engine room somewhere, Paul. Is our senior wardroom officer, Paul. We have our chief mate. Up there from the north, Standing Officer Gillis, thank you for duty.
I work for a living.
Our Master at Arms, Senior Petty Officer Scarborough, making sure everybody stays in line, does what they're supposed to do. And then, of course, we've got the guy who holds us all together. He's the rope maker, Senior Petty Officer Chuck. I'm sailmaker, Petty Officer Ross. And I am super pleased to let everyone know we've got our visiting explorer scientist, Ezequiel Benitez, and I did an interview with
everyone.
I don't think I've done an interview so far where the guy was just laughing the whole time. So he said, "Do you want me to send you something on my bio?" I said, "Hey, this is what the phone call was about." I knew it was going to be easy. This guy's awesome. You all will love his photos. And I know two of them worked for us, Ezekiel, so maybe we can show the first one.
Is it there? Okay.
The one with the roll-off observatory, Ezekiel. And that's pretty cool. And I know you've got a good story to share with everybody about this roll-off observatory you built yourself in Puerto Rico. Here is almost up.
Yeah, that one. So that rollover observatory, I built it myself a few years ago on 2017. So it have 2 rails, 4 wheels, and it's the best investment that you can do when having, a telescope, a big heavy mount, because everything stays there, and it's just a matter of opening the observatory, pushing it, and in 10 minutes you're ready to go.
Yes.
Ezekiel, what do you have in there? What kind of mountain scope you have?
Well, I have my telescope is a William Optics 4-inch refractor. I have an Orion Atlas mount, an Attic 460 mono camera.
How do you like that camera?
I love that camera.
With your Atlas, I've got an Atlas also. I actually have an Atlas and the Skywatcher, which is like, I don't know why I have 2 of the same mounts. But did you get lucky with your Atlas, or did you have to tweak it?
Well, I have everything connected to Sequence Generator Pro. That's the software that I use. And so far, I haven't had any problems. Everything connects without any issues. So it's a good thing. I haven't had any problems at all.
I mean, that observatory you built, Ezekiel, it's pretty sturdy, isn't it? It can stand up to just about anything, right?
It's hurricane proof.
That's what I was going at.
Yeah, a month after it was built, we got the visit from Hurricane Maria, and you know that it was a high-end Cat 4, almost Cat 5 hurricane. So I put everything inside my home, the equipment, but the observatory stayed there and it survived without any damage. So it's hurricane proof. So I think I'm a great builder then.
You are obviously a great builder.
How close are you to the sea, Easy?
Well, and how long have you been imaging for, Ezekiel?
I started on 2013. So that makes 8 years of experience of imaging. And I always been concentrating in I shot 80 millimeters refractor and a Canon,
Mhm.
not modified one, and a Celestron Advanced BX mount without any guider. So I started like doing 60 seconds photograph.
So was it the Arecibo, the big satellite telescope? Did that spark your interest? How did you get interested in astrophotography and astronomy?
Well, a few things. First of all, I always like, to see the night sky. And I remember that when I was on 6th grade, my father, he bought me my first telescope. It was a Tasco telescope.
Mhm.
And with that one, I was able to see, you remember comet Hale-Bopp?
Hale-Bopp, yeah.
Yeah, so I really have a lot of fun looking at that one and the
Well,
planets.
that's one of my first memories.
Everything started
of the
there.
sky. Yeah,
That's
Hale-Bopp's one of my
right,
first
that's right.
memories. Yeah.
And I'm still waiting for some bright comet to come, because I really love to imagine them. The last one was Lovejoy,
Mhm.
and I took some good picture of it, but I'm waiting for another bright one.
Well, why don't you show us? I can't. Which galaxy was that? It was the Needle that you had sent me. Was it the Needle galaxy?
Yeah.
Okay. Will you share that one with us? Because we didn't. That one didn't go through.
Okay. Let me share my screen.
It didn't go. No, that's not. The
Oh well, there's one there.
Yeah, that one's great. I was gonna save that one for the end because that was my favorite.
Yeah.
But go ahead and tell us about that one, Ezekiel. It's super beautiful.
Yeah, that one. Its name is Ghost of Cassiopeia. It's a 2-panel mosaic. So you know that mosaic is a pain to do because everything needs to be in alignment. But this one, it won Image of the Day on Astrobeam.
Oh, that one won.
So, yeah, it won.
All
So
right.
it was a great achievement. Because this one is hard. First of all, because this is with hydrogen alpha and RGB.
Mm-hmm.
So is that combination, and secondly, that bright star that you see there is really hard to keep that in control, because the more you increase the signal or work with the histogram, that star will bright crazy. So I needed to work with
what kind of exposure time did that have, Ezekiel?
I believe 10 minutes on at least on hydrogen alpha. So RGB, I believe it's 5 minutes. Yeah, 10 minutes. So that Atlas works well.
No, but how many? What was your total? What was your total?
Total exposure time of the image? 16 hours.
So, okay. I thought it had to be a lot. Yeah.
Yes. Yeah. 8 hours per panel. So.
Okay.
Basically.
Per panel, yeah.
Is that easy? Is that in Cassiopeia? Which one is this?
Yes, that constellation. Cassiopeia.
Right in the middle of the W, right? Is it right by there?
Yeah, I believe it's right there. Of those bright stars that you see there.
Yeah, and I just want to emphasize.
Exactly which one?
Yeah, that's Gamma Cassiopeia, I think.
Gamma, yeah, and you know what? You're right, Easy. I was trying to image that myself, and I just want to re-emphasize for all the viewers here, Easy is right on. It's very difficult to take any nebulosity. This is a very faint one. And as soon as you have a bright star, it throws off the histogram, as you mentioned. So what happens is your signal to noise and your adjustment is so much biased up that to be able to stretch it and pull out that faint nebulosity, because it's all at a low level. Very low level. It's not like the Flame Nebula that's close to Almach, right?
Right.
And Orion, where the Flame Nebula actually has pretty high surface brightness in that. But this one here is a really tough one. So yeah, this is a fantastic shot. Good work, Easy. Really good.
Thank you very much.
I really appreciate that.
Well, yeah, anytime you're next to that really bright star, I think in Leo, there's next to Regulus, there's a dwarf galaxy, and just the dynamic you need to achieve is It's really
I
hard.
haven't done that one, but I think it's on the agenda.
Yeah, well, mine
That should
too.
be a tough one too.
Well, show us some galaxies, Ezekiel, because we would love to see that.
Okay, so I have I'll share my screen. Share. I have let me know if you can see it.
We see your thumbnails.
Yeah.
Yeah. You see it now?
Oh, wow. That's
There
nice.
you go. Yeah. Beautiful. Look at that dust.
This
Taurus
is Centaurus A galaxy, and this one is on the southern hemisphere. So that's why it's a great target, and a target that we are able to see from Puerto Rico. You know that we are in the Caribbean near the equator, and we get to see some of the southern objects. Only a few degrees over the horizon, but we
Hey,
get
zoom
to see
in on
them.
that. Zoom in on that, because I want the audience to see, because I did it myself, and the details are mind blowing.
Gorgeous, and I love you kept the star colors too. Really, really nicely done.
Thank you. So this one only have 5 hours of data, but I only got like 1 hour available to image this at night because it was so low in the horizon. So it took some nights to get those 5 hours. But this is one of my favorites because of the shape the galaxy has. It's not your typical galaxy shaped. And since it's more in the southern hemisphere, you don't get this one photograph too often. So a good achievement.
Hold on right there. I keep it zoomed in. I just want to point out a couple of
camera did you use for that one?
Ezekiel, your wife is on. She said Easy is the best, not just because he is my husband.
My wife is there.
Here.
That's awesome.
That's cool.
Hey, Easy, can you zoom in just a little bit more? I want to. I just love to point out some structure here. So that's perfect. One thing I noticed that's really interesting, I didn't notice this until now, until your image, is you see how the dust lanes kind of fan off, actually not on axis. So you have the main axis. Usually you see this central piece, which is kind of going top left to bottom right. But now you see it, the upper dust lane is actually veering to the north, to the upper part, and the lower dust lane is going to the south. So they're actually skewed a little bit, which is really fascinating. I didn't know it had that kind of offset structure. And then if you look carefully at the upper arm, you can see that kind of brightening, which is basically either globular clusters or star clusters in the arm structure itself. So that's actually extragalactic stars that you're seeing, star clouds.
So awesome. It's so awesome.
That's
awesome.
really great. I didn't know that.
Beautiful image.
Know that. Thank you for that.
We have a couple of questions from the audience. One person wants to know, Ezekiel, what is the dimensions of your observatory?
I think it's about 4 feet by 4 feet, and 8 feet tall.
So it's
I
like
believe.
It's just a tall box, kind of.
That's right. That's right. Enough for everything to fit in. So I only have a 4-inch refractor, but if in the future I bought a bigger one, so probably I won't supposed to have any problems because you can put it like in this right direction.
Right.
Will be enough. But so far, no problems on that. But yeah, to anyone interested, it's really a time saver. I remember before that I spent like 1 hour just putting everything into a cart, pulling everything into the backyard.
Yeah.
You spend 1 hour setting everything up, and then guess what? The clouds come in.
Yep.
Yes.
Every time, yeah. Yep.
And you do have a lot of patience. Put everything back and go home.
Yeah.
And now I do everything in 5 minutes.
Yeah.
Well, hey, I forgot to mention to everybody that the ship is flying in hyperspeed today. For the next 2 months, I'm gonna be coaching a T-ball coach pitch little team, and so we're gonna have to make it back home a little bit quicker. But you all, our audience probably doesn't know that Ezekiel is, not only a good dad and obviously a great husband, but he is also a YouTube star.
Nice.
Oh, very
Yeah,
cool.
I
Yeah, share your
All
website
right.
real quick with us, Easy.
well, well, I'll show you my website pretty. Let me, because I love to teach as well. So my mom, she's a teacher. So I just opened a new YouTube channel. Let me. Here it is. This is my channel. So I started like 3 months ago. So I guess we are increasing subscribers. I'm doing all kind of videos, but mostly tutorials videos on PixInsight to help people or teach them tips of how to process the images. It's mostly in Spanish, but I'm planning to add subtitles in the future so everyone can see them and enjoy them. So
We've got a great
I
international
also
audience. Yeah, we've got a great international audience.
that's right.
So y'all,
That's
everybody
what I'm
go over
looking
there
for.
and give some love to the man who is captando el universo. Che, Ezequiel,
right.
un abrazo fuerte, and thank you so much for sharing our pictures. It was Ray Sarpado, Che. Ray Sarpado.
Do we have time for another question here?
Oh yeah, definitely.
Yeah, okay. So Josh Kovac asked, he said, so I like to keep a bright star in my framing near the deep sky object that I'm shooting at as a kind of reference star. Is there anything special I should be doing in pre-processing to account for that histogram difference? Now, this guy is using PixInsight. So you got a faint galaxy or faint nebula and a bright star,
Yeah, well,
I don't know about PixInsight, because I mean Ross uses PixInsight. I use Photoshop and Lightroom. Also, I have a ton of plugins, but something like that. I mean, I'm just gonna keep my eye on the histogram to make sure I'm not clipping data. But I mean, for me personally, I would use a plugin for either. There's so many plugins, and I know there's a lot more in PixInsight because PixInsight has its own plugins. But basically, I mean, so you're trying to keep that star bright, but also keep the galaxy in there. You can brighten your stars in a lot of these plugins, and it wouldn't affect. Then also, you can circle around that galaxy so it's not taking data away from it.
You can make a mask.
Yeah.
I decrease the dynamic range a little bit in the high levels. And you can, a really big star is tough to mask, but I would just, the highlights at the top end, you don't have to worry about that too much. What our guest Casey Good came on a few weeks ago and talked about sync, scan, stretch. It's in the transformation section on PixInsight, and I arc sign stretch, and that is really good. I used that for the first time after Casey's recommendation, and it works really well. So
yeah,
I'm not the expert, but in PixInsight, but I've seen some videos and stuff where they do dark star masks. So what you can do is you can have some shorter exposures for just the bright star, and then put those frames as a mask. And then what you can do is you can process your nebulosity or your fainter object, do all the stretch on that, and that will blow out the big star. But you can mask out that overexposed star, and then replace it with the other shorter image of that star. That would be, I think that there's something you can do with that. That way
I believe it's
you can
called
treat them both
HDR,
as two layers.
HDR composition. Yeah, there's a feature on that on PixInsight. But the key is to make mask for everything, for the faint galaxy and for the bright star. And you can decide how much are you going to stretch each one. So that's pretty much is
Yep.
the key. Yeah.
Yeah, that's quite a little project.
It's
I mean, it depending on what program you're using, but
mask are hard. Well, hey, Standing Officer Gillis, it sounded like you were getting in pretty deep. Are you ready to go deep with us? Take us deep?
You bet, sir. All
All
right,
right.
mates. Let me just quickly share my screen here. So basically, just a couple updates since the last time. Whoops, let's see. So what I've done is in my adventures in my Astronomy Sky Survey, as you know, I've been working on calibration frames and such. And I've been working on masters now, master darks, master bias, and master, and I got a chance to try them out. So basically, just to kind of refresh everyone, what I found, here's my master dark. For this is a 5-second master dark, and you can see the spread of noise. You can see the amp glow on the bottom here, and this top right. And then to compare that to an individual, here's an individual dark. You see all this line noise, and if I start going through each one, you'll see the noise move around. And the problem is, if you only use one of these, you're gonna throw it off. You're gonna throw off the noise. So you have to actually stack all these guys together to make your master, and then so you end up with a master like this. And then if you go on the bias side, here's my master bias. You can see it's relatively equally bright noise. And if you go into individual, you can see how these line noise moves around, just like interlacing on your monitor. So basically, when you blend all those two together, you end up with this type of master. When I do the masters, I ended up with pretty good results. So here's an example of the. Let me just put this in full screen. I love this nebula in Aquila. Basically, you can see massive field rotation. I have an alt-azimuth mount, and of course, when I'm doing this is 185. This is only 5-second stacks. 185 5-second stacks, and you can see nice flat frame, very good detail. Obviously, there is noise still because of the it's an uncooled camera, but you can get quite a bit of detail. And of course, there's invariably an Elon Musk Starlink satellite that comes through. But the point is that a very nice clean image. I can just crop it, of course. This is an example of, I love the wild duck cluster. Nice, evenly bright with no line noise anymore. So nice clean image here. And then if I go to some images I took last night, or actually this was, I'll skip these guys.
So how much sleep did you get last night, Cameron?
Actually last night was good. It was 2 nights ago I didn't get much sleep. I probably got about 4 or 5 hours, but I'm all good now. I got my coffee, so I'm all hyped up now.
Good.
So.
Yeah, that's right.
And then just to show you, I took what I learned with flats. This is an interesting thing. So I took a couple of flats. So here's a nice flat. This is on the lower end, and then if I compare this. This is what it looks like. You can see it gets rid of the vignetting here on the corners, and then this is another flat with which is more centered around 24K, and again the corners. But the point of this is you don't. I realize this is what happens when you stack flats. Some interesting behavior. So this is some weird patterns with the Bayer matrix. And if I zoom in here, as I zoom in, it goes through different levels of combinations and based on the resolution of your monitor.
Yeah,
so if I keep
that's resolution. Yeah.
So basically, as you start going, you start seeing the Bayer matrix. So what I've learned is that I can get away with doing with master bias and master darks. That's where you want your master frames. But because your flats are pretty much way to the right. If you look at the distribution, you're way above the noise. You're already here at 25 because you're so amplified. Your noise, you don't really need to stack your flats. That's what I found. You just need your latest, greatest flat, and that seems to work really good. That's all I need to do. So that will save, that's what I found, at least with my processing. And so that will be a good time saver for folks. And you'll get the results that you want. And basically what I had, just to show you my images here. Yeah, let's go to, here we go. And then just 2 nights ago, you can see this was at 1 o'clock in the morning, Thursday morning. And this was some galaxies in if I go here in Pegasus, I go, this is Aquila. So basically go to Pegasus, NGC 7332. If I zoom in, there we go. And this is a nice pairing. And if you actually look at what I've learned, I have a nice little sneaky way of doing my, I've really optimized my process of my sky survey. I take a screenshot on one of my tablets that's using Sky Safari, which does the tracking. So here's a screenshot. It has the time stamp. It has all the information, the size of the field, etc. And then I can, and then I just go to the right, and there's my image. And on the other tablet, you can see it's a nice flat image. This is only 5-second stacks, by the way. So this is a beautiful pairing of galaxies, perpendicular to each other. And you know, this is like a 12th magnitude galaxy here. This is like a 10th magnitude galaxy, and just a really nice pairing. But you can see how flat it is right to the corner, even with the vignetting. The flat brings out the stars right to the edge. And so I'm getting very happy, very good results. So this is just 5-second stacks, and yeah, and basically with one single flat frame and my master dart. And a master
unmodified camera, right?
And unmodified camera, no cooling. And so great. You know, if you can take images like this, it's pretty decent. You know, I'm pretty happy for, especially for the sky survey and for the catalog. So so that's basically it. And yeah,
that's awesome.
Yeah. So I just wanted to.
I know Cameron, you took us all over on your sky survey, and I'm feeling lost now. We're gonna have you know, our coordinates back, that trigonometric, you know, kind of like an earthquake, and what's, you know, the red shift. We've got to figure out where we are. We got to crunch a constellation with Chuck.
All right.
Yeah, today I chose to do the Hercules Consolation. Of course, it was named after the Greek hero Hercules. This constellation is mainly in the northern, or it is the northern sky constellation, actually. But Hercules, in turn, was actually associated with the Sumerian hero Gilgamesh, and this constellation itself has a long history dating back to Sumerian times. Hercules, of course, was the son of Zeus and Alcmene, a mortal woman. When he was an infant, Zeus laid Hercules at Hera's breast, which while she was sleeping, having he sucked the milk, Hercules became immortal. Hera was enraged by this and made Hercules' life very difficult at every turn. She cast a spell that made him lose his mind and turned against his children. Once he regained his senses and realized that what he had done, he visited the oracle at Delphi to see what he could do to undo his deed. The oracle sent him to serve the king, Eurystheus, for a period of 12 years. In that time, let's see, I got lost, I'm sorry. Actually, that also means the glory of Hercules, another name, of course. But during that time, basically, Eurystheus gave Hercules 12 tasks, which he succeeded and actually was able to get out from under his grip. So with this constellation, they're really, I mean, there's basically, in this constellation, it's mostly like globular clusters and galaxies. Ooh, I lost my mic. Sorry.
It's all right.
Our mics went off earlier. That's why no one could hear me. But so in this, you got Messier 13, which is a very famous globular cluster. It's very, very bright. Also with Messier 92. But as far as galaxies, there's 300 galaxies in this constellation, and they're pretty much all very deep. So if you have a big telescope,
they're far.
Yeah, not even that big of a telescope, you can, you know, image most of them. So if you're looking for a galaxy to shoot, I would definitely look at the constellation Hercules, because there's a ton of them.
Yeah, it's got a lot of. I mean, but they're far. I would recommend at least a 5-inch telescope if you want to get much detail on any of those. I know I took, and dark skies and dark sights of course. But I do feel like.
Yeah, I was gonna show a couple of images. If I
Oh
could real
yeah.
fast. Yeah. So I was able to get a little imaging done this week, and I found an old image that I really like because we actually have a comet coming our way, and so this is an old picture of comet Neowise, which I took. I think it was a little over a year ago. So I took this with the Canon R8. You can barely see it down there.
Oh, I see it.
Yeah, but it's peaking. This is when it was really, really low on the horizon. The only time when I got to imaging it, basically right after sunset, it was just on the horizon. But it's a neat little picture. And another one that I did this week was the Cygnus Wall. But unfortunately, I had to change it to a JPEG, so all the color is pretty much gone.
But it's still awesome. Dude.
Yeah, you can
it's
see
still
all the
so good.
Yeah, you can see all the detail and stuff. But I shot this with Explorer's ED127 with the FCD 100 glass and our 0.7 reducer. This had the ASI 533 MC Pro with the L Extreme filter, and this is, I believe, 5 hours of data. So I really liked how this one turned out. If you go to my Instagram, day and night photography, you can see the image with the real color in there.
Yeah, it's gorgeous. I could stare at
Beautiful.
Cygnus like that for a long time.
Yeah, I want to do a mosaic of it just because you get all that. You just have all that dust flying around everywhere, especially. So where the Cygnus Wall is, if you go a little bit higher, there's like a huge hole, and around that hole is just dust being thrown around.
That's where Ezekiel is. That's the Gulf of the Gulf.
Okay, nice.
Yeah.
But yeah, I just wanted to share those two real fast.
Yeah.
Well, that was great work you did this week.
Nice.
We've been doing a lot of work this week, and so that's kind of what I try to do. I try to figure out what's been going on this week and how to bring it back. And thank you, because I do think we've gotten our coordinates now, and we can set the ship to home. We're gonna head back, and I know it's Friday. It's almost 5 p.m. We're all tired, and it's been a long week. So tuck yourself in. Sailmaker Ross is gonna read a little story time to everybody, and I have a lot of different things I wanted to talk about, things I could have talked about. I got a call this week from a lady who she needed to get that telescope back outside so she could start looking at the stars again and remember her husband. And so I talked to her, and she was the sweetest lady. And she got it set up, and it took about an hour and a half, and it was a long phone call for me. And now I'm in QC, which I love, and maybe because I was talking on the phone too much. But there's a bunch of stories and a bunch of really cool things that happen, and I've been getting to work in QC. Chuck and I have, because Chuck and I, we love telescopes, and we want to know everything about how they work and how to make these little slight adjustments, because that's what astrophotography is. It's making the teeny tiny adjustments to get that perfection. It's taking the time. I must have spent an hour and a half, 2 hours today collimating one scope. And now I still am beginning, and I still really don't know quite what I'm doing yet, but I'm going to do it right, and we're going to make some really awesome scopes, and it is awesome. So we're really happy about that. We couldn't be more excited. I will miss getting to talk to our customers for 2 hours on the phone every time they call. But some of you all might have my cell phone number by this point. So if you do, I'm still around. And so we do have a story, though, and we were tasked with writing a description of the show. And Kent was gone. He just left. He's going to a really awesome place in the panhandle of Oklahoma to go camping. And so, he wasn't able to give us much inspiration for our story, but, he did give us the name. And he did give us the theme of the mothership. And so I started going back to like the 1920s and a fair. And so we've got our description of the story or of the show, and I think we've kind of figured it out now. I think you as guests have kind of figured out where we're starting to go, how this ship flies, and so here's our show. All aboard, tourists and travelers, explorers and scientists. Please take your seats on the mothership. We are so glad you are here, and we're not exactly sure when this ship's going to take off, but she's already flying fast. And, so whatever you brought on board the mothership today, whatever brought you here, whatever got you to board the ship today, whether it was Hubble's iconic image, that view of the pillars of creation, the one we all remember, or maybe it's that quantum mystery that is light, or maybe it's just that one night when it really felt like the sky just opened up just so you could see Halley's Comet. And, the mothership, it really is anchored to the stars. And if we get everything aligned, if we get it all aligned just right, maybe when we come back, we can have a picture. And so by focusing on astrophotography, we get closer to these things we can't reach, things that we could never even see, the faintest of nebulas that are just now becoming visible. Tonight, and last night for Cameron, a 500 million year old wave of light crashed into his camera and became a particle again. So come with us and collect the ancient photons. Friends, the mothership has landed, and wherever it takes us, we are going to try to capture the moment. So hop on board, buckle up, and enjoy the ride, because by the end of our timeless journey, we will be a little better at seeing what is up there. And the trip is fun, and with prime focus, we'll explore the themes of astrophotography. We will witness gravity at work as Chuck crushes constellations right before your eyes. You will elate in our international guest, like Ezekiel, and everyone we've seen to have so far. And, they always seem to add a few nanometers to that full spectrum of light. And you will reignite your youthful imagination as you tug yourself into story time with Ross. So thank you for choosing to travel on a ship built by the explorer scientists themselves. We know that you have many options for interstellar travel. Fellow stargazers, you have made a wise decision. Things are getting funky. The mothership is grooving. And the crew here at Explore Scientific will try our best to always focus on astrophotography. So that's it. We are home. We have made it back. Another great episode, guys. Thank you so much.
Thank you, Petty Officer.
Right. Thank you, Captain Scott.
Awesome.
Hey, thank you.
Yep.
Thank you,
Before
Sergeant
you
Phillips.
guys go, okay, and for our guests here, we got 4 of you to answer this question. What is your favorite Hubble image and why?
Pillars.
Yeah. And in a minute.
Oh, and why?
1 minute. Okay. What would you say?
Well, the pillars of creation were mine. I saw it when I was a kid, and I just remembered my dad telling me that's where stars are made. And I didn't understand it. It didn't make any sense to me, but it was awesome.
I think mine's the pillars too. Because I remember, okay, so even though I didn't get into astronomy till I was till 2016, I remember when I was a Cub Scout, I remember we went on a camping trip, and the guy had, he brought his telescope and he had it set up on Saturn, but he also, he did astrophotography, and I have no idea what he was using, but he actually put it on the pillars of creation. All I can remember is I think he had like a Celestron, maybe like a C11 or something like that, old orange and black.
Mm-hmm.
But he put it on the pillars of creation, was able to stretch it. And whenever the pillar creation, I remember it was always in our textbooks.
Yeah,
school.
It was. Yeah.
And so, I mean, that honestly, I would have to go with that too, just because I was actually able to see that as a little Cub Scout, but also it was all over our science books pretty much.
How are you, Easy?
What about you? What about you, Captain?
Yeah. Well, for, well, for me, it's a M51 Willpower Galaxy because of the way those two bright galaxies are interacting together. Is crazy. And you can see all these tiny details on the main galaxy. And one thing that I really love is the amount of hydrogen alpha that you see also on that galaxy. It is crazy. So that blue with red and yellow for me is something amazing.
Yes.
For me, I have two that are really kind of give me the overview effect. One is the protoplanetary disks in the Orion Nebula. Seeing those accretion disks around stars with the bubbles,
Yeah.
and seeing that those were actually solar systems. That was very profound.
Insane.
When I saw that, it was like, wow, there we go, solar systems being born. That was very profound. And then the other one, of course, is the Hubble Deep Field. That one, when you just keep on going, and there's thousands and thousands of galaxies in a very fraction of a degree. Those two were really incredible to me.
Yeah. No, Cameron. Yeah, you always have such awesome additions. The one in Orion you're talking about was just fantastic. Yeah, the accretion disk. When I saw that, it was just like, well, yeah. I mean, there it is. That's obviously what's happening. So
yep, there's life somewhere else for sure.
There is.
I think Hubble has shown us.
Yeah, what's yours, Captain Scott?
Well, I think Hubble's images overall have shown us just this continual destruction and creation process that's going on in the universe, you know, and it's and the amount of detail that we were able to see in these objects is just, you know, it more than pulled the curtain across. It allowed us to see things that that were invisible to us before.
Yeah.
What's really cool about it is the amateur astrophotography connection to Hubble, in as much as that amateurs are now making exposures with stacked images of 40 hours, 50 hours, 60 hours, 100 hours, okay, whatever it takes, so that they can get the light and much of the detail that was actually revealed by a lot of the Hubble images. One of the images that I love, it's a series of images of Supernova 1987A, and just all the dynamic activity that was going on, just the symmetry and beauty of it, and just knowing that, okay, this supernova was in its death throes, but it's something that is going to make new stars, new planets, new everything. So it's just a constant rebirth, renewal, destruction. This is how it all works. So.
Scott, that's the one with the expanding shell of gas, right? Where you can see.
Yes.
Over time,
it looks like it looks like pearls of illuminated material around it and stuff. And it's these three rings that come out. It's amazing. Awesome. And they still photograph it now, and will continue to do more. So.
Awesome. Well, hey, I did want to forget. I did not want to forget. We've gotten a couple questions in customer service about putting a guide scope on. This is not for your guide scope. This is for your finder scope. On Explore Scientific, when you want to put your guide scope on, all our rings will have this handle. You take the handle off, and this, you can put a dovetail bar there, and that's where you're going to attach your guide camera. It's going to be much more stable. It's the way to do it. And it will work perfect. So that's how you do it. Take your handle off and you can start guiding.
Also, if you don't have an extra, you can use the handle.
Oh yeah, you can go on top of the handle too.
Just make sure it's tight. But I used to do that with my 102, and I never got flex or anything like that from it or anything like that.
Yeah,
so.
No, I didn't ever get flex. I just wanted to keep the center of gravity as low as I could. But yeah, you can go on top of the handle too, for sure.
Beautiful. Well, great. Well, thank you guys. Thank
All
you,
right. Well, thanks for
Ezekiel,
flying with us
for
today.
Thank you guys
coming
for
on
inviting me.
today, and wishing everybody out there clear skies. We have a great little kind of about a 10-minute video coming up, and we will show the what some of the scientists, JPL scientists, and other people may be involved with Hubble, what their favorite Hubble image is. So you guys have a great weekend, and I hope you enjoy.
Thank you.
Thank you. Bye-bye.
Hi, my name is Paul Morris, and I'm a video producer for the Hubble Space Telescope. Over the years, I've had the amazing opportunity to interview some of the brightest minds in astrophysics and some of the coolest astronauts and people in the world. As a rule, I always ask every single person this one question, every single time.
This is the cliche question.
Always
What
good.
is your favorite Hubble image?
Oh, whoa, is my favorite Hubble image.
Can you talk about your favorite Hubble image? What is your favorite Hubble image and why? What is your favorite Hubble image and why?
I began to see a pattern in their answers.
The Hubble Deep Field.
The ultra deep field.
The ultra deep field, one of the questions you were going to ask me was what was my favorite image? My favorite image is the deep field image. It's because it's one that tells an incredible story about our universe.
Back in 1994, Robert Williams, then director of the Space Telescope Science Institute in Baltimore, Maryland, came up with a plan. He wanted to point Hubble at a spot in the sky where there was seemingly nothing there. A lot of scientists and astronomers at the time thought this was a huge waste of valuable Hubble resources and pushed back. Williams, however, continued forward with his plan. He controlled 10% of Hubble's observation time, known as Director's Discretionary Time. He decided to use some of that to take a long exposure that would be made immediately available to the public. Taken over the course of 10 days in 1995, the Hubble Deep Field captured roughly 3,000 distant galaxies in various stages of evolution. 3,000 galaxies where it seemed like there was nothing. The world was stunned.
When we finally looked at what came back, it was one of the most mind-boggling images of the whole Hubble collection, galaxies with billions of stars and billions of planets we know nowadays. And guess what? One of those planets in this image may have somebody like you or me or some other intelligent life form that we don't even know about yet. So we got to keep searching. We got to tell that story.
The deep in Hubble Deep Field refers to the telescope's ability to look at some of these far, faint objects. Looking at faraway objects in space is like seeing back in time. Light moves at tremendous speeds, but it still takes time to travel across the vastness of space. Even the light from our own sun needs 8 minutes and 20 seconds to reach Earth. So when we look at the sun, we see it as it was a little more than 8 minutes earlier. The farther away the object, the younger it appears in Hubble's eyes. The deep field was like a core sample of space, showing galaxies at different and earlier stages of development, the deeper they appeared in the image. Science and astronomy is all about honing and improving our senses. No one expected the Hubble Deep Field to have thousands of galaxies in that single image.
We thought X, and we were so wrong. And that experiment, it took great engineering to do with a great system, Hubble, allowed the astrophysicists to say, hold it, it's different. It helped connect the dark energy, dark matter theories to what the light we can see is. And for me, it's beautiful because it's like looking into a pond and seeing the water molecules and the living cells that are micron around of the microbes. It's like that kind of moment. It must have been like the early microscopists who first looked at pond scum and said, "Ooh, geez, there's stuff going on," or Galileo when he first sensed the satellites of Jupiter.
Since the original Hubble Deep Field, Hubble has gone on to collect over 20 deep fields of various parts of the sky in multiple wavelengths of light. To create each image, it has gazed at the same point in space for many orbits, gathering as much light as it can. Every single one of these increased our knowledge of the universe and our place in it. The Hubble Ultra Deep Field, for instance, released in 2004, had a longer exposure time than the previous deep field. This new snapshot contained even more galaxies of various ages, sizes, shapes, and colors. The smallest, reddest galaxies may be among the most distant known, existing when the universe was just 800 million years old.
When I stare at that image, my imagination goes wild. I wonder what it would be like to visit any one of those little smudges of light, which would be presumably possibly similar to our own Milky Way galaxy. And also realizing that if we extrapolate that image to the whole sky, that's what our universe looks like. In any direction, we see a collection of galaxies like that.
The width of the Hubble Ultra Deep Field is less than 1/10 the diameter of the full moon. That's like looking through the eye of a needle held at arm's length. And in that tiny space, we found 10,000 galaxies. 10,000 galaxies in that single space. 10,000 galaxies in that one too. 10,000 galaxies there and 10,000 galaxies there. 10,000 galaxies there and 10,000 galaxies there too. If you add them all up, that means the entire observable universe is estimated to contain at least 200 billion galaxies. 200 billion galaxies. If each galaxy has an average of 100 million stars in it, then that means there are at least 20 quintillion stars in the observable universe. That's a 2 with 19 zeros after it.
It makes me, of course, just overwhelmed, but also just very curious about, wouldn't it be wonderful if I could just beam myself over to one of those galaxies and explore around and see if they have stars and planets like we have in our own Milky Way, and just be amazed, not only at the magnitude of the universe, but to be grateful that I can be a part of the universe and have the ability to look out and see this grandeur. That's what I love about the ultra deep field, and that's what I love about astronomy images in general.
Inspired by Hubble's deep field, other NASA-grade observatories would go on to take deep field images in their own wavelengths of light. These observations continue to make NASA science even richer than before. The Hubble Space Telescope has helped us take a step forward in understanding our place in the universe. With Hubble's mirror acting as our eyes, we are just starting to perceive the real universe, and the deep field images are yet another step forward to a brighter tomorrow.
The image itself might not look as beautiful as a single spiral galaxy where you see all the stars. But what you're looking at is a tiny little part of the sky, and they found thousands of galaxies in that tiny little spot. And so you see this image, and the ones that are a little closer to us, you can see some detail on. You can actually see that they're spiral galaxies or kind of blobby elliptical galaxies. They're actually beautiful little galaxies in and of themselves. Of course, they're not little, they're just very far away. But then you see this background, which really just becomes dots. And each one of those dots is not a star, but a collection of hundreds of billions of stars, just so far away that it appears as a dot. And some of the smaller dots in that image, you're looking at galaxies as they were, more than 10, 11 billion years ago. In this tiny little dot in the sky, you can look through it and you can see the history of the whole universe. And so when you see the Hubble Deep Field, I can feel, the hair rising on the back of my neck, and I'm getting goosebumps even just thinking about it. Through a tiny little pinhole, you can see the whole history of the universe right there. That's the Hubble Deep Field.
Wow.